So we're going to talk about microservices. So if you're already familiar with them, this could be some review. Hopefully we're adding some value. Microservices, again, being a key pattern in terms of digital transformation, as well as into the componentization, application modernization. So lots of flavors here and lots of complexity to it. So all of these things we want to keep in mind as we're moving through the discussion, and feel free to raise a hand or jump in. I think most everybody's muted, but you're more than welcome to unmute yourself, and I'd be happy to bounce questions. So let's see if we got anything here. Please show the slides. I am doing that. Thank you. There we go. I think we're good. Okay, I'm getting my cue. So now we've got the cue card set up. Thank you, Alex. All right. So the first thing that we're going to really drill into in terms of this is really the notion of what is it we're doing. What are microservices? So microservices themselves are really an extension of service-oriented architecture around creating distributed systems. So we're running microservices typically as processes. In some cases, we'll run them as containerless processes, which is funny because the other part of that is, so we're running them without a application server per se, J2EE or other app server container, but a lot of times we're running them within a containerized environment. So it's containerless, but containerized, which is also very confusing, quite honestly, for a lot of folks. So services themselves, of course, have to be able to interact. I mean, if we think about this, if we're moving into an architecture where we're breaking things up into many service interactions, composition of services in this case, putting one or more services together to actually get us a response, and then typically we'll see this into something that's either a single page or multi-page web application, but then services can be consumed for anywhere. And the key here as well is, right, the notion of microservices, whether we're composing them or we have something that's actually allowing us to do a transaction, is to really solve business solution problems, and we're really looking at transactions here. So the microservices are exposed by APIs, and then you get into a whole host of things that we're not going to spend an awful lot of time talking about, but around API gateways, API management. Many of the pay-to-play software vendors have solutions in this area. The IBM API Connect, CA has their solution, HP, a lot of vendors in this mix as well. So keep in mind that there are, not only is there the notion of programming and reference architecture for microservices, but as you move into microservices, there's a lot of bits and pieces that you would have to learn. Some people would use MQ or a Kafka or something, even less costly or less supported in terms of this, like RabbitMQ, things like these, messaging platforms, and lots of other ways we can serialize the data in a RDBMS or like a NoSQL database, not SQL or NoSQL from that perspective, but not only SQL, of course, when we start talking about that, or even into a service that actually consumed or was using information out of real-time or data at rest from big data, a Hadoop cluster or otherwise. So lots of different patterns. We can use that API to in this case, we use typically a publish and subscribe mechanism, but there's lots of other ways that we can create a producer and a consumer. So a service itself is a producer, clients or other services as consumers, and all of those are valid patterns in terms of this. So collaborating with each other in a decentralized fashion, but really giving us that ability. For instance, if I have a service that's providing data cleansing for customer, order, package data, whatever it happens to be, I can then, of course, use that in other applications. So now I'm starting to look at the idea of, I'm creating a service that I can actually ramp up separately from the rest of the application stack. Now, and we'll talk about this in some of the different patterns as well, the difference between, really monolithic applications and something that's microservice-based or decentralized, distributed, similar to what we saw, in the move for a lot of companies from mainframe, mid-frame computers into client-server technology. So very similar, and if you think about it, there's some of the There's some reductions in complexity in some areas and some significantly more complexity in other areas. So all of it is a pattern that requires us to continue to understand that evolution. And this is an evolving technology space, not only with microservices themselves, because, you know, quite honestly, a lot of this has not been very widely used, except for a few, quite honestly, born internet and other companies from a microservice containerization perspective. But from service-oriented architecture, you know, something fairly well known and used in many organizations for years, if not over a decade now. So adoption in this case ties back again into this whole notion of continuous integration and continuous delivery. So CI/CD, and of course not, you know, we're not talking about compact disks or certificate of deposit here, really into enterprise application integration patterns that allow us to more simply identify where we have opportunities and continue to shift left in terms of testing some of those other things. And we'll drill more into, you know, some of those areas as well. So if this was what you were expecting, great, welcome. If it wasn't, feel free to pop in questions. So the next thing we're going to talk about is this notion of, you know, demystifying microservices. And like anything else, when you first look at something, a lot of times it can be confusing as to what it is. So if I take this little blue thing on the top right-hand corner, this graphical image, and I ask people what that is, a lot of times I'd have a variety of different answers. So number one, I would have people saying that this is a Norelco shaver head. It, in this case, is not. Other people would come back and say, well, it looks like a shower head. No surprise, because we have it blue coloration. And then finally, we realize that this is just a collection of one, you know, LED light that's then transferred in a graphical, you know, in this case, graphic designer approach to using a light bulb to do something fancy. So microservices, you know, at the simplest, are really just a componentized application, but there's way more complexity that can come from that. And so here we really look into that demystification. So if we think about this, one of the analogies that you'll see online, and there's other ones that are actually part of this. Similarly, when we talk about technical debt, people will use mortgages and debt financing as an example of that. Here we're talking about the linking of, you know, simple Unix commands. So you don't have to be a Unix person to actually, you know, understand this example. And of course, it never hurts to have a little bit of Linux or Unix in your background. If you don't already, eventually you will see some of that as well. Or in some cases with microservices, we can encapsulate them in Microsoft containers in Docker or some other mechanism, and all of these things, you know, play together. People are moving more and more into some of these service-oriented containerized environments, even within the Z-Series OS390 IBM mainframe environment. So expect that you're going to see this, you know, touching anything that you work with, because quite honestly, no matter whether you negotiate contracts for vendor management, or you do something in terms of M&A activity, or you're a developer or an architect, microservices plays into your world in a lot of different ways. So here we're basically, you know, using a cat command, which is throwing out a set of CSV files, assuming that there are some within this folder that I'm in. I'm grabbing for a pound sign, and then I'm counting the number of lines. So this is counting the number of lines in all of the CSV files in the folder that I'm at. And so what we're seeing here is 3 different commands, and if we think about it from a perspective of microservices, we have one service that's providing authentication, authorization. We have another service that's providing us the ability to get customer information. We have a third service that's managing catalog information. And then finally, we put them all together to create an order item. So we have an order service that's most likely tied to that, as well as an orchestration service, which is using all of these different areas to do some business transaction. In this case, the example I gave would be somebody adding something from a catalog into a shopping cart as a registered user. So the solutions in this case created from those, you know, suites of loosely or slightly coupled cohesive microservices. So why is that important? Because then I can scale up my order microservice without having to scale up my catalog or my customer microservice in the example that I just provided, or the authentication and authorization service. So all of these things allow me to very closely target, you know, what's needed in terms of growth, in terms of platform. Now, that creates a lot of complexity in some areas, and so we have to think through that. It also creates opportunities for software vendors to create solutions to fill those gaps, and so we'll talk through a number of those different areas or areas of interest. So from this notion, when we think about it, this whole idea of monolithic versus microservice. So a lot of people would characterize an EAR with many WARs as being a monolithic application. There's lots of other examples of these monoliths in terms of standalone applications that we can create in Microsoft technology, in Java technology, and in other spaces, because there's lots of different ways to create microservices. A microservice can be a C#, Go, Kotlin, Spring with Java, and lots of other frameworks in terms of Java for creating these services. So when we think about it, here our goal is really to break apart this monolith into pieces. And even that, when you think about it, is going to be an evolution. Because if I have an application that I'm modernizing, do I immediately take something that's large and most likely interconnected with other applications and break it down to microservices, or do I piece it out piece by piece? And so we'll talk about some of that. So on the left-hand side of this picture, we're showing, the different icons in terms of these boxes represent our different areas. So if you see, there's 5 of these different areas within this, and so I have a top kind of a apostrophe or quotation mark looking service. That's my that's going to end up being my authorization. As I move around, clockwise, I have my diamond-looking order service. I have a triangle, that's my catalog service. I have a roundish customer service. And then finally, I have, some monolithic shopping cart service in this case. And I'll use the word monolithic because here we're actually, in some cases, composing services to make them more significant. And when I do that, I could have wrapper services that are actually doing some of that interaction as well. So I may create larger services that are actually wrapping individual transactions and then using other microservices to actually complete that transaction. So here we're seeing every time I spin up a new app server, I have all of those services represented. However, in the case of the example on the right, you'll see that I could have a specific set of services at a disproportionate number in terms of the instances that I'm running. And so here we're seeing that we most likely want to have at least 2 of each service running in different environments, because we want to still have high availability and disaster recovery, business continuity, all of those kinds of things. But the idea here is that as I scale up, I can move, for instance, more instances into my order service. I can actually spin up more into my customer if I need it. And that way I have less impact in terms of running infrastructure for services that are not really required to scale up. So now I'm scaling in a more targeted fashion as opposed to a more scattergun fashion. So when we think about this from the qualities of a microservice, we have to get into the notion of what it is that we're actually creating. So componentization, of course, tied back into this, I'm going to organize them by business capabilities. So I've got order, catalog, customer, data cleansing. What are these services that I'm actually putting together? And I'm creating those as products, not projects. Why? Because now I can align, 1 or more services to a small Scrum team or small Agile team or even small waterfall team. And in many cases, of course, as you're probably well aware, a lot of organizations are really doing optimized waterfall rather than Agile anyway. So this notion of smart endpoints and dumb pipes really gets us, here we're connecting messaging or some backing store, and that backing store could be messaging, it could be a database, it could be RDBMS, it can be NoSQL, lots of different options that we can have for that. And then, of course, we're starting to think about decentralized data management. So when we talk about that, we have APIs that we're exposing in front of this microservice. We have a backing store, and that data is represented in the picture on the right as really what looks like a database, but it could be anything. I mean, literally, if I'm creating an app and I'm doing it in a design-first approach or mobile-first approach as well, I may be writing in this case into some kind of even text stream And then when I'm done with my first iteration and I'm ready to take it enterprise, maybe I'll create the database based on what I've learned and my initial understandings of the data management that was required. So the infrastructure automation comes into the idea of putting microservices into Docker containers. And we'll talk a bit about that as well. And then, of course, this notion of design for failure. So that gets us into the idea of cattle and pets. And we'll talk a little bit more about that. And then, of course, lastly, back to where we started earlier in this thread, which is really an evolutionary design. So we're not revolutionizing the industry. We're not turning the application upside down. What we're really doing is looking to slowly evolve from a more monolithic approach for applications to something more evolutionary. So then we start to think about this, well, we could be building cloud native apps. Well, first of all, we have to decide, if I'm an organization that's actually using cloud or not. What is it that I'm actually allowed to do within that environment so that I can decide, whether that's going to be cloud specific or it's going to be something else. You can take over if you want. And so all of this gives us this, mixture of not only cloud, but then how are we going to manage all of this? So here we're showing an application that's using microservices on-premise as well as using microservices in the cloud. So all of that gives us a significant amount of complexity. If you think about it, all of this is designed to make it less complex in some ways, and we'll talk about that, and in other ways it makes it significantly more complex. And that complexity is represented partially in this picture that we see right here, giving us that idea of microservices being spread over many application architecture components, and then how is that going to be managed? This creates more opportunities for people to actually literally learn new skills, because when we think about it, if we're using Docker, we're using Kubernetes as a container management platform, we're using some of these other technologies, we're writing microservices in languages that were not part of the core feature function for the application development group that I'm in, or operations group that I'm in, or business group that's using and consuming these applications, from an ideation. Am I actually creating them as MVPs? So not the, most valuable player that we'd be familiar with from either, American or international football, but really the idea that we have, this minimum viable product. So we're really looking at something that's actually a mixture here, and we may want to do something like this for many applications. Why? Because in some cases we have data that we really don't want in the cloud. We have data that we want on-premise so that we can keep it within our four walls. But as you think about this, one of the key elements in all this is also security. Because as I move into these containerized application environments, I'm greatly increasing the volume of moving parts and automation, and all of that creates opportunities for people to figure out how to insinuate themselves. And in many global enterprise organizations, you would see a significant opportunity here for actually people to start to slide through the gaps. And if you think about it, if a lot of people are suddenly doing microservices development in an organization and it's not something that they're intimately familiar with, are they really going to be great at it right off the bat? So we want to create reference architecture, and we talk about that as we move through this process. So key components of this successful microservices team really start to look into this notion of, accountability for the consistency, automation of cattle in this case, because of course the cattle and pets metaphor, where pets, of course, we maintain, they're cared for, they're family members. When we start talking about automation, we're really, and cattle, we're talking about a service becomes overwhelmed, we spin up more. A service starts to degrade, and don't use this example with ranchers, but you shoot the cow and get another one out of the herd. And then the culture of containerization. So the interesting thing, of course, is that people will say that microservices, especially in environments like Spring Boot, are containerless. But if you think about it, we're going to run them in Docker containers. So we're talking about containerless from an app server environment, but containered from a specific, runtime containered Docker environment as far as that. So then when we move back into the notion of some other areas, we're really looking at DevOps, this collaboration, this idea of gold master in terms of examples and standards. So we'll drill more into that, because that idea of gold master or reference architecture is key in every organization from an app dev, operational perspective. Because again, like anything else, you need examples of how this is going to work to show people how they're going to use it. And if they don't have those examples, how are they going to really be consistent? How are they going to, really stand on somebody else's shoulders? Or are we going to fragment the organization like we see with a lot of people doing DevOps? So microservices architecture itself, and this whole notion of designing for failure. So think about it, any service in this case can fail. So anything can fail, and we want to design for that idea of failure. I mean, once we start thinking about, failure, then we come up with all sorts of other, ways that we want to architect to make that simpler. And so the idea here with microservices as well, and especially when we get into containerization, is that we could spin up additional services. And why is that important? Because if I can spin up additional services, what I'm looking at is actually the ability to, reduce unplanned work. And unplanned work is a key area for almost everybody in terms of reducing technical debt, and then also in terms of this whole move into DevOps. So detecting the failures, well, that's the work of not only the people that are involved, but we're trying to automate this and reduce unplanned work. That gets us into container management platforms. That gets us into lots of other areas that we're not necessarily going to start out to be, the triangles in the organization. So like anything else, we have people who are starting out. Those in a Kaizen skills matrix would be our circles. Those are everybody who's starting microservices would be starting out as a circle. As you move forward and you become better at, using microservices, and you actually can create your own without having to have the interaction of a consultant or another person on the team who's actually better at it than you are personally, then we're starting to move into being a square. And then finally, once we become a subject matter expert in microservices, we become the triangle. So of course, nobody really starts out as a triangle. That takes expertise. That takes more than an hour webinar with George. That takes more than a training. That takes people actually spending time working on it. And most of the time, it requires us to have teams doing that. And then creating our gold master. What is it that's our reference? Something that allows people in the organization, for each organization, in terms of knowledge management, whether you're doing console-based microservices with Microsoft technology, you're doing Java, Spring Boot microservices, Node, something else, because there are a lot of different options here. What is it that you're expecting people to do? Because the more you let microservices fragment the organization, the less likely you are to ever become triangles in that specific technique around the microservices application and modernization. So of course we have to have monitoring for all of this as well, because the monitoring, we're trying to put in analytics and monitoring up front. Why? Because then at this point, that consistency. And it goes back again to this notion of gold master. So it's not only the service, it's not just the Java or Ruby or Go or C# coding that we're doing that's the important part of this. It's all of the services that are wrapping around it. And when we talk about services here, we're not talking about microservices, we're talking about backup, we're talking about audit, logging. How is it that you're getting consistency from all the services that you're developing? Because if we're moving towards a notion of application modernization, we really need to get to much more consistency across most global enterprise organizations. And so lastly, they touch on here, this notion of not only the chaos monkey, but the Netflix simian army. So if you think about it, they're introducing issues into everybody's daily environment from development all the way into production to allow people to become better at creating resilient services. So rather than doing a once a year, HADR failover test, we're talking about bringing things down on a day-to-day basis and then making people recover gracefully. And that graceful recovery you'll see exhibited on the Netflix application. So early on, and it's less likely that you'll see this now, recommendations would disappear. And so no surprise, the recommendation server would get overwhelmed, but the Netflix application would continue to service requests for, people to watch or binge watch their favorite shows, as the case may be. And you may be familiar with that, or you may be somebody who regularly binge watches on Netflix or one of these services yourselves. So microservices in a nutshell. So if you think about it, this whole notion of shift left is about trying to, it came from earlier wording from Gartner and Forrester and IDC research around fail fast. But again, nobody wants to fail, and least of all do it fast. So here we're talking about this idea of not only not failing fast, but trying to get to an understanding of the application health and do so in a way that allows us to reduce unplanned work. So the microservices architecture, because of the factors of DevOps and automation that really come along with it, especially if you read on what is started here, because Docker containers and microservices themselves are really part and parcel of the world of Google, Red Hat, of course, and both of those companies being the #1 and #2 committers on the Docker container project. So why is that important? Because watching the people who actually created this pattern and how they use it is good in terms of understanding what the future is. Because again, today somebody will release something like we just saw with Capital One's Hygieia as a telemetry mechanism, as we saw with Netflix Conductor as an orchestration mechanism. Both of those things will 3 years from now be supported by some company or companies, and at that point become more and more part of the enterprise, because a lot of enterprises are still not the people who early adopt open source. They really look for a throat to caress in terms of the ability to have somebody to help them lift up on shoulders and do these things. So from a competitive advantage, well, if we think about it, clean, well-managed services give us ability to use the agility and velocity, but we're also always measuring that in terms of quality. So agility, velocity, and quality being our key metrics of not only the services themselves, but when we start to talk about monitoring, about ramp up, about the evolution from, large, monolithic, huge applications. Many organizations have 5, 10, 15, 20, 30, 50 more apps that they all move in these giant enterprise release cycles that are done, anywhere from 2 to more, 3, 4, maybe a few more times a year. And why? Because even though they're disconnected by using messaging, the applications are still required to be around. And so there's more to it than just services that are going to allow us to grow into this growth, but they are one of the key architecture patterns and development patterns and operational patterns that we're seeing people making use of. So then from a technology-enabled business, if you think about it, technology-enabled business, microservices allow us to more simply snap things together from existing components. As we create a library of services, or as we're using SaaS services, because many organizations do, using applications that are SaaS, the APIs that FedEx or UPS expose in terms of package logistics, the APIs that Amazon exposes for retailers or eBay for people using their site, all give us an idea of a componentized API that we can use to do something rather than rebuilding the wheel ourselves. Now, sometimes we may wish to do that, because again, when we move into this notion of competitive advantage, let somebody else maintain the pieces that are commodity for us, and then we actually do the work in our services and in our applications that actually take them and turn them into something special. And then lastly, we talk here into this notion of gold master. And why is that important? Because again, without examples, an architecture pattern that sits in a book or sits on a web page and doesn't give me code that allows me to do that is problematic. And microservices gets us into this idea of, instead of need to know, we expose the information across the organization because we want the consistency. It's unlikely that someone's going to lift up most microservices from any company, put them on a thumb drive or email them or some other way, walk them out of the company and do anything with them somewhere else. Really, we have to get to much more of an open kimono. And there are things with it that still should be, behind the four walls for sure of any organization, from a DMZ, a firewall, a security, InfoSec perspective, a data management perspective. All of those things are not what we're articulating here. Really what we're saying is if you're going to create 1 or 2 really best practice patterns, then you better have the code to back them up in terms of how you're going to roll those out. And then of course the pipelines and processes into things like Jenkins around CI/CD or some other continuous integration console. Am I using Docker containers? Am I using a cloud provider? Am I using multiple cloud providers? All of these things add additional complexity, and of course before we put our mission critical apps on a microservice framework, we better have people who understand how to support that as well from a Gold Master perspective. So the run book for what a microservice application looks like within our organization. So Docker and microservices, again, go pretty much hand in hand. Why? Because that's, everything in Google runs as a containerized service. And some of those things are, of course, monolithic applications that are running within their container framework. But we have to think about it, do we want to just take our ear files and move them into an application server containerized, environment from one of these open source or pay-to-play vendors, or are we really looking to get more from it? Really, it's this notion from Unix of, doing one thing and doing it well. So the idea here is that I'm breaking apart the application into services. I may still have an ear file that's actually using those services. It's not impossible that I wouldn't still have something from a client-facing perspective that I really want to put more, more effort into. I want it to be something bigger, but I could as well be moving to single-page applications tied to services for this matter. So the idea is running, each service as a process within a container, and a lot of times, especially in the Spring environment, Spring Boot, we're looking to do that in a container-less environment. We're still, funny enough, running in a web container, but we're calling it a containerless environment because it doesn't have the monolithic application server wrappings that a lot of these, ears and also, non-Java applications can have in a .NET or other environment. So we have to modularize things. So this idea of decoupling them, in a lot of cases, if I have a service that can't do anything without interaction with another service, I may be decoupling them, but I'm still looking at, what is it that I'm doing in terms of passing information between them. So I have to modularize them, and I want to have consistency even in the way those APIs use. I would like to, if I could in an organization, have a common, set, but a lot of times we need to have a not one size fits all, because again, with microservices, especially in most enterprise organizations, I may have a Windows flavor, I may have a Go or a Ruby or a C# or a, I guess that goes back to Windows flavor, or a Java flavor service in terms of this, and I may have to have patterns for both of those. I may be using the same underlying backing. Am I using Kafka? Am I using, a backing store that's data related? Am I using a Couchbase, or am I going to use something that's a traditional RDBMS? Because I want to, have some different levels of control and data management tied there. Because, the thing is people will call, RDBMS legacy. They'll call, mainframe legacy. Legacy is the word that people use when they want to throw something out the door. And there are places that all of these technologies can still play in a future environment. It really depends on what, the time, talent, and treasure is within your organization as to how you move forward into not only microservices, but DevOps. Most people would say they're doing Agile, but quite honestly, when you look at it, a lot of that is optimized waterfall. So when do you get to full Agile with MVP and the rest of it that we mentioned earlier? So architectural patterns enabling this whole notion of continuous delivery. Why? Because now services, as we're moving them through the scale, of course, if I'm talking about into a CI/CD pipeline, I'm packaging them, I'm putting them in an environment as they're proven to be correct through automated risk assessment. I'm moving them through environments, and ultimately I could be doing trunk-based development or continuous, in this case, deployment, where I'm moving things directly from developer checks it in through this automated pipeline into production. And still many organizations, having that stage gate or that gateway between their last non-prod environment and production, that in many cases, I would say is probably still recommended just based on process that people have. So single page applications. So no surprise, our SPAs are really web apps that look like a single page, and we're rendering our views dynamically. Basically, we're in a lot of cases we'd see people seaming this together as multiple single page applications, because you have one that's actually tied to authentication and authorization, and then you shift off into a catalog view or an order-centric view. A lot of different ways that we can see this. So we can have SPAs that are working in conjunction with each other, seaming them together. And of course, once we start to move into anything that's more complex and more enterprise, we have to have ways to walk across those different components to understand what is, working and not working, from a goal of many organizations to be 100% regression testable. Well, if I'm linking together SPAs or services, I have to make sure that I can regression test across all of the consumers that are using that producer from a service level. So whether I'm sending requests or I'm doing AJAX calls, so I'll send an initial request, I'll get the initial output of the page, and after that I'll be driving AJAX requests to continue to update the page. If I was to move to another SPA, normally I'm going to actually invoke a specific HTTP or HTTPS request, excuse me, redirect to that next SPA, and then again move into this AJAX callback mechanism, rewriting specific areas of the document object model within the page using a combination of HTML5, CSS, and other technologies, of course, some of the nodes, the Reacts, Angular, all of these different JavaScript technologies that give us the same notion of building these front-end UI-specific applications that are using services as well as backends to solve business problems. So Spring Boot is an example, and of course just one, having been around for for really a short period of years from its RFC to its actual release. Not surprisingly, talking about containerized web applications in a containerless environment, which is very, very confusing. So when we talk about it, the containerless part is I'm not running in a Tomcat, I'm not running in necessarily a WebSphere or WebLogic, a JBoss, an ATG environment, although still many people do run services within those environments. So Spring Boot itself, coming from Drop Wizard, and there's other frameworks, the RESTlet, Vertex, there's lots of other ways that we can see service development in terms of Spark, which is not only Hadoop tooling in Cloudera, but also a mechanism for doing microservices. So some of those different overlaps, again, in terms of just wording that you'll see, because not surprisingly, people use the same words to mean lots of different things, not being a synonym here, because Spring and Hadoop and Spring and microservices is clearly not a synonym for people who have used both. So really giving us a way to package something as a jar file in Java as an XC when we start talking about microservices in Windows typically, and at that point I'm running that as a standalone service within a containerized environment. If I need more, I spin up more, but I'm getting to a really componentized architecture as I'm doing that, and I can chip off pieces of a monolithic architecture and create shared services, and then hopefully expose those from an API gateway. I've got API management that I need to do, and some of that can be provided by special purpose tools that you can buy off the rack, and you may have some of those. Can be tools like the IBM API Connect and lots of other similar mechanisms for doing those kinds of activities. Really getting into the governance, compliance, management, architecture, because governance and compliance and architecture and InfoSec and data management do not go away just because you're using microservices. And of course, one of those key things that we always see, design does not go away and documentation does not go away. A microservice is not self-documenting unless it's very, very complex in terms of what you've done for annotations, and you can do annotations that will provide some of the context of documentation, but it very, very seldom is that going to create us the business case documentation around how it's used, what the actual use cases could be for it, some of the usage patterns, and then what's the best practices around using that service. All those things are less likely to be annotations than they are to be documentation that I'm creating for the service itself. And of course, as we mentioned here, there's Spring Boot is just one of many excellent choices for creating microservices. The C#, the C++, Node, Ruby, Go, and other Java frameworks all give us a mechanism. So where is it that we go within that as an organization to understand? So from a data management consideration, if you think about it, if I have 800 tables in a database under a monolithic application, am I breaking this up into 800 different databases with one table and then seaming things together? Most likely people would go into affinity groups, and that's what this represents. So I have a products, or a catalog, I have a shopping cart, and an order database which I could actually share. Those could actually end up being the same in terms of this, possibly. And then I have accounts, I have a customer database, I have an authentication and authorization services. So all of these areas giving me a set of components, that I can couple together to create applications. So once I have a catalog service, I could use that under multiple applications. I can create microsites and other mechanisms in terms of SPA, single page applications, to actually drive out the use of that, either decomposing services from a monolithic application, or in some cases, the whole notion of composition when I'm using multiple services to do a specific task, as you would see in most cases when you're doing anything complicated with a business problem. And so when we talk about state, of course, no surprise, the state in most monolithic web apps is passed around based on a session environment, session information. And of course, that session information can be serialized on the application servers. The application servers themselves have to be in a trust domain. So there's a lot of complexity there in terms of how that works. And no surprise when we move into state in microservices, basically we're passing the state around, typically in terms of our JWT payloads, but there are other ways in terms of session cookies and similar mechanisms that are available but are being repurposed. And so what your pattern is depends on what it is you're going to do in environment. If your microservices are all going to be Windows, you probably have one mechanism. If they're all going to be Java, you have another mechanism. And if you have combinations, you may be able to share, but it may not be one size fits all. So keeping in mind where you're going to store state, how are you going to rehydrate state when a session, when a specific service degrades and has to be, taken out of the herd as the cattle mechanism and then replaced. So JSON Web Token is one of the key pieces of a lot of binding between microservices, and you'll see JWT used in many enterprise companies currently, as well as growing in terms of that market share. Why? Because JWT, or JSON Web Token, which funny enough is a encapsulated set of acronyms, so JavaScript Object Notation Web Token, so JWT in this case giving us the ability to digitally sign the messages so that we can pass around our authentication and authorization information. And of course the JWTs themselves, we want them to be fairly shortly lived. And that depends on the application itself. How long that lives depends on what your requirements are, but we're looking at something that's actually going to expire so that we don't, give somebody authorization for the rest of their natural existence necessarily. And then also moving into this notion of possibly I could be giving you a number of different types of payload here. So I have a header, which is giving me essentially the signing and tokenized algorithm around this in terms of the JWT, and then I have its payload, or its claims in this case, and the payload itself can be a nested set of similarly to YAML dictionary and lists. So service fabric, so if you think about it, if we're going to take a monolithic application, we're going to lift and shift that and start to move it into this microservices environment. Are we doing it as a big bang, or are we doing it in small chunks? So the idea here is typically we want to look into this notion of minimum viable product, because big bang is not minimum viable product. It never likely will be until we get to a bit much smaller, big bang than what most people use. So the idea is not only I'm taking that original application in a box, I'm moving it into my containerized application modernization environment. I'm starting to write microservices that run alongside of that monolithic application. So I'm moving it into my new world of virtualization, containerization, cloud. I'm then piecing off services from that. Eventually I start to move enough into services that I've, purely based on need and prioritization. So again, I'm refactoring that based on time, talent, and treasure to get to a fully microservice-based application. And then when you think about it, when I move out of that, I've got something that finally looks like it's decoupled and composed and has lots of components as far as that. And then, of course, I have to run it. So it's how do I get into microservices, how do I run them, and how do I get out of a particular microservices pattern as these patterns evolve is all something that I need to keep in mind. So that was our session. Thanks for joining in. You're welcome to jump in with questions if you have them. We'll deliver the deck after this session to you. And of course, as always, as WebAge, not only are a workforce provider, but we also do consulting in microservices, as we've done with many organizations in the enterprise over the last year. So shameless sales pitch, feel free to use us as a coach, a mentor, a facilitator, a trainer, because not only do we teach a lot of enterprise companies how to use microservices, but we do a lot of that work ourselves in terms of architecture, delivery, development, operations around this. So applying DevOps, agile architecture in terms of microservices, design thinking, customer centricity to your patterns, and of course understanding where you are, understanding where you want to go, and then creating a roadmap to get there. So if you have questions, feel free to flip them out. If not, I won't say I give you back 10 minutes of your day, but you could repurpose the next 10 minutes of your day if you haven't already figured that out from the question slide. And if not, thank you for your time. Feel free to connect. Again, my name is George Neese, and I'm always happy to connect with anybody, technology, business, or just general nerdery, and you'll find me on LinkedIn. Of course, there's no requirement to be a LinkedIn person to be doing microservices, but it never hurts to have, a network of people that you can ask questions to. So thank you again. I'll stick around for a handful more minutes, and you're welcome to bounce off, stay, listen, participate, all of those things encouraged. So thank you very much.